Hello everyone, welcome to today's lesson. Yesterday we just had our big chapter 8 test, which was on polynomials, and there was a lot of factoring involved, and overall the class did really well. We are starting chapter 9, and chapter 9 is all about quadratics. Okay, so we're going to talk about quadratics a little bit more. Hopefully you guys remember what a quadratic was from chapter 8, but if not, we'll go back over it. And there's two things that we're going to talk about today. One thing, by the end of the lesson, we want to be able to identify different properties with parabolas and quadratic equations. And then the second one is that we can graph quadratic equations. Okay, so those are the two objectives for today. We talked about a video. I'm going to skip the video since I'm already doing a video. First off, a quadratic function, or sometimes called a quadratic equation, is written in this form. Okay, so you guys are used to a linear function being written like y equals mx plus b. Right, well, that's a linear function. If you remember from chapter 8, a quadratic function has to have an x squared. Okay, and it's still going to be y equals out front. But it's going to be y equals, now there could be a number in front of this x squared, or a coefficient, we call those. So we're going to use the generic letter a. So it could be anything x squared. Sometimes there will be a middle term where we call it b. Again, that can represent any number. And it will be accompanied with the x. And then sometimes it will also have a constant. So it could have all three of those things, or it could just have the x squared part, because for it to be quadratic it has to have the x squared. The other two things are optional, and they just give us more information. And we're going to kind of, this section we're going to study, what does the c term do? How does it change the graph? What does the b term do? How does it change the graph? And how does the a term change the graph? Okay, so that's going to be section 1 of chapter 9. All right, now we call this form, when it's from the highest exponent to the lowest exponent, we call that, as you guys probably remember in chapter 8, we call that standard form. And it's the standard form of a quadratic, since the exponent, the highest exponent, was 2. All right, so let's learn some more about quadratic equations. So anytime you graph a quadratic equation, you're going to get these U shapes, whether it's an upside down U, and again that goes on forever, or whether it's a right side up U, or sometimes I'll call it frowny faces versus smiley faces. And what the name of those graphs are, those U-shaped graphs, they are called parabolas. That's how you spell it, parabolas. Okay, now all parabolas, what's kind of cool about them is that they have what we call symmetry. In other words, the left side looks exactly like the right side. And I could even draw a line right down the middle of those U-shaped graphs, those parabolas, and fold them in half, and they would match up perfectly. That line is going to be really important, especially this first few sections of the chapter. We call that line that divides them into the matching halves the axis of symmetry. And in a few days from now, we're going to learn what moves the axis of symmetry. But for right now, that axis of symmetry is always going to be right in the center of our graph, which is the y-axis. So for today, the y-axis is always going to split our parabolas in half. Okay, so let's talk a little bit more about the parabolas. So we're going to talk about just this a term first. Okay, so the a term, if it is less than 0, in other words, if it is negative, When I think negative, if I'm thinking smiley versus frowny, negative is the frown shaped graph. So anytime that a term is negative, we have the upside down U, or the frowny face. We say that that graph or that parabola opens down. Now, if it opens down, there is always a turning point. And what I mean by turning point is if I go from left to right, this graph is going up, 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 and it starts right here to go down, 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 down. Okay, so this turning point right here is either going to be a max or a min, depending on if it's the highest point or the lowest point. Well, this turning point was the highest point. So that turning point is the maximum. So anytime it is going to open down, it will always have a maximum. Whereas if A is positive, or A is greater than 0, when you think positive, oops, did not spell that right. When you think positive, you think smile. So this is the graph that looks like a big giant smile. So it opens up. It goes up and up and up forever. And its turning point, it was going down, 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 stops right there and starts to turn around and go up, 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 up. So that turning point this time was the lowest point on the graph. And so we call that turning point the minimum. So anytime a graph opens up or a parabola opens up, it will always have a minimum. Okay, so every parabola will either have a highest point or a lowest point, and we call that point the vertex. So the vertex is always either the highest point or the lowest point. And to be more specifically, the vertex could either be a maximum or a minimum. Okay, so we just hit the first standard. We talked about some different properties of parabolas. We're also going to now start graphing them. Okay, so when we graph, a lot of times we will choose the same 5x values. We like to do 2 negatives, 2 positives, and 0 right in the middle. And we choose small numbers that are easy to work with, hence why we chose -2, -1, 0, 1, and 2. Okay, so here is our equation, y equals x squared. Remember, we're going to take out the x, and instead of the x, we're going to put in parentheses. So if I put in parentheses squared for each of these, and then I'm going to plug in the 5 values. So I'm going to plug in -2, -1, 0, 1, and 2 to see what we get. Most common missed ones are the negatives, so be careful with that. -2 squared, or -2 times -2, is a +4. -1 squared, or -1 times -1, is +1. 0 squared, 0. 1 squared, 1, and 2 squared is 4. Because it has an axis of symmetry, we should see what I call the rainbow pattern. Okay, so -2's answer should match 2's answer. Okay, so if we graph these points, go left 2 up 4, left 1 up 1, right at 0, 0, 1, 1, and 2, 4. And I'm going to connect my points and makes that U-shaped graph, and I'm going to put arrows showing that it goes on forever. Okay, so we graphed a quadratic to get the graph that looks like a parabola. Now this one has a turning point, or the vertex, right there at 0, 0. So any basic quadratic that only has an a term, so when it only has the x squared part, like these two examples, will always have a vertex at 0, 0. And if you remember, I said that all of them today should be centered right on that y-axis. That y-axis is going to split it in half. So if I folded my parabola, it would match up perfectly. To be even more specific, that vertex is the lowest point, so that is a minimum. I know it doesn't ask that, but it's good information to know. Okay, so this one does not have any other term except for the x squared term, so the ax squared. So I know that the vertex is going to be at 0, 0. All right, but this is always one that confuses students in terms of order of operations. So I'm going to rewrite this as -1x squared. That means the same thing. Okay, so if you think in terms of order of operations, we see multiplication and we see exponents. So in PEMDAS, we have multiplication and we have exponents. Exponents comes first, then multiply. So we are going to have to do the x squared, and then we're going to multiply it by -1. Okay, again, I could show my work here by writing out that formula for each one. And I would plug in my 5 values. So -2, -1, 0, 1, and 2. So square first, then multiply. So -2 squared is +4. Then I multiply it by -1 to get -4. -1 squared is 1. Multiply it by -1, -1. 0 squared times -1, still 0. 1 squared is 1 times -1 is -1. 2 squared is 4 times -1 is -4. Okay, so let's graph our points here. So left 2 down 4, left 1 down 1, right at 0, 0, right 1 down 1, and right 2 down 4. Again, draw the arrows showing that goes on forever. We did have an A term that was negative, so we knew our graph was going to be flipped upside down, and that vertex is the highest point, which is a maximum. All right, let's try a few more, but let's add something other than just the A term. So we know the A term, if it's positive, it's a smiley. If it's negative, we're going to flip it upside down and make it a frowning face. Let's now see what a C term does. Okay, so we kind of know what an A term does. We're not going to talk about B term today, but let's find out what the constant does if I add a constant to the graph. Okay, so in terms of order of operations, we have squaring and we have adding. Exponents definitely come before adding. So in all of these, we're going to take it to the second power, and then we're going to add 1. All right, so -2 to the second power would be +4 plus 1, 5. -1 to the second power is +1 plus 1 is 2. 0 to the second power is 0 plus 1, 1. 1 to the second power, 1 plus 1 is 2. And 2 to the second power is 4 plus 1 is 5. And remember, we should see that rainbow pattern here. All right, so left 2 and up 5 actually goes off my graph. Left 1, up 2, just up 1. Right 1, up 2, and right 2, up 5. All right, so let's talk about some of these things. Our A term was 1. It was positive. So our graph is a smiley graph. We have a vertex at 0, 0. That is, or sorry, not 0, 0. Our vertex is no longer at 0, 0 because of that +1. It shifted our graph up 1, and so our vertex is 0, 1. It is the lowest point on the graph, so it is a minimum. And let's try one more like that. Okay, this time we're going to see what a negative does, a negative constant. Okay, so order of operations. We're going to square our x, and then we're going to subtract 3. All right, so let's plug in -2 first. If I plug in -2, I'd get 4 minus 3 is 1. -1 squared is +1, minus 3 is -2. 0 squared is 0, minus 3 is -3. 1 squared is 1, minus 3 is -2. 2 squared is 4, minus 3 is 1. Again, we should see that rainbow pattern. So left 2, up 1, left 1, down 2, down 3, right 1, down 2, and right 2, up 1. All right, so let's talk about some of the properties again. All right, our A term was 1. That means it's going to open up with a smiley face. So we have a minimum. Our vertex is a minimum. And our vertex, again, is not at 0, 0. Because it was a -3, it shifted our graph down 3. Our vertex is 0, -3. Okay, so let's put this into writing. When there is a C term, our parabola shifts up if positive and down if negative. So our new vertex is always 0 and whatever the C is. All right, so I'm going to go ahead and pause now and have you guys try these last two problems and see how you do. Okay, so go ahead and pause and then we'll go through the answers. All right, here's what you guys should have gotten. So we're going to do our x squared and then we're going to subtract 2. I already know our A term is 1. I know it's going to open up. I know our C term, our constant, is -2. So I know our vertex is going to be at 0, -2. All right, so let's kind of plug these in and check everything out. So if I plug in -2, -2 squared is 4. 4 minus 2 is 2. -1 squared is 1. Minus 2 is -1. 0 squared is 0. Minus 2 is -2. That's good because this should match that. If I plug in 1, 1 squared is 1. Minus 2 is -1. 2 squared is 4. 4 minus 2 is 2. Again, we see our rainbow pattern. All right, so our graph should look left 2, up 2, left 1, down 2, right 1, down 1, and right 2, up 2. Oh, I didn't graph my first point right. That should have been right there. And connect our points to make our smiley face here, our smiley parabola, or right side up parabola. And in case you're wondering, our vertex here was a minimum. It was the lowest point on our graph. All right, let's try the tougher one here. This one has 3 steps. Technically, there's a -1 out there, squared, and a +3. Order of operations, we do exponents, then we multiply, and then we add. So in this case, we're going to square our x, we're going to multiply it by -1, and then we're going to add 3. All right, so let's go ahead and do the math here. -2, I'm going to go through my checklist. Squared is 4. Multiply it by -1, so -4. Add 3, I would get -1. All right, let's go through it again, this time with -1. So let's do exponents. -1 squared is 1. Times it, or multiply it by -1, we get -1. And we add 3 to get 2. Let's do 0. 0 squared is 0. Multiply it by -1, still 0. Add 3, we should get 3. And this matches our vertex that we know is 0C. So that's good. All right, let's plug in 1. 1 squared is 1. Multiply it by -1 to get -1. Add 3 to get 2. And last one, we have 2. 2 squared is 4. Multiply it by -1 to get -4, and add 3 to get -1. See a rainbow pattern? That's always a good sign. So now let's graph our parabola. So go left 2, down 1, left 1, up 2, up 3, right 1, up 2, oh, just 2. And the last one I went up 4, sorry. All right, so right 1, up 2, right 2, down 1, connect our points, draw the arrows showing it's going down forever. This time, our A term was negative, so it should open down. It's the frowny graph. Our vertex was 0, 3, since we had an A and a C term. And then last, that vertex was the highest point of the graph, so that was a max. All right, that's it for the lesson today. Tomorrow's lesson, or actually Monday's lesson, we're going to figure out what else A terms do other than just if it opens up or down. And I will see you guys then. Have a great day. Bye.